Hey guys, so it's Dr. Hammer here, and I'm hoping that this will offer a little bit of support to the work that you're doing at home tonight. And in general, when you use these videos, my recommendation is always that you try to work the problems yourself first, and then turn to the video for some help. And the nice thing is that you can stop and restart the video wherever you want. So, okay, here we go. So I'm on the Review 1 worksheet, and I thought I would maybe use number 4. That's not one of the ones that you were assigned tonight, so I thought I would use that as another example to sort of illustrate the metric unit conversion process. Okay, so let's see here. What do we have? Let me get my pen working. So you're working with, okay, let me get the pen operating here. There we go. So we've got grams, right? And we've got to go from grams to micrograms. So if I flip over to the metric staircase, okay, grams is, that is a base unit, okay? So back on the problem, the way it's stated, there's no prefix here. It's not kilograms, it's not micro, it's not milligrams, it's just plain grams. So that's what you would call just the base unit. And then we're trying to get from just regular grams to micrograms. Okay, just being sure. So we need to end up down here on this step, right? So how many steps is that? So we have to go from grams, 1, 2, 3, 4, 5, 6. So that's 6 steps. And in order to set up the equivalence statement, so that's the very first thing and the most important thing that you have to establish when you're doing unit conversions. My recommendation when you're using the metric staircase is that you always start by listing the unit on the top, the one that's furthest up. So here it's just plain grams. So we'll start by saying 1 gram equals, and then it's going to be 10 to some power of micrograms. Okay, so if we have to jump down to micro here, then that's what I put on this is on the right side. And we said there's 6 steps, so that's 10 to the 6th power. And you guys know that 10 to the 6th power is 1 million. Okay, so here's an example. Here's 10 to the 6th. I'm using watts in this case, and that's 1 million. So it takes 1 million micrograms to equal 1 gram. Okay, so there's our equivalence statement, and now we're going to take that back over to the worksheet, and we're going to exploit that in developing our conversion factor. Okay, so now I'm just going to reproduce the value that we have here, so 0.0025 grams. Now we are ready for the conversion factor, and if we set that up appropriately, we should end up with micrograms. So which one do you think goes on top, gram or microgram? Well, one way to remember this is the units that you want to end up with need to be on top. Okay, so I would recommend we put 10 to the 6th microgram on the top and 1 gram on the bottom. And the other reason that this should make sense to you is that you want to cancel out the grams, right? So that you're ending up with micrograms. So there you go. And then now that we have our units figured out, now we grab the calculator and you multiply 0.0025 multiply by 10 to the 6th. And when you do that, let me do that myself real quick, times 0.0025, and I get 2,500. All right, so it's 2,500 micrograms. Okay, easy. All right, let me try maybe one that you were assigned. Let's see. I think you were asked to do number 6. All right, so let's try number 6. So in this problem, we got 6.2 micrometers. So we're going from micrometers to just plain meters. So over here on the metric staircase, let me erase this stuff. Okay. So we're starting from micrometers, and now we're going to go to just plain meters. So we're starting here this time, and this time we're going to go up the staircase, right, to the base unit. So we're starting with micrometers, and we're just going to end up with meters at the end, which is the base unit. So now, it's just the reverse, actually, of what we did in the previous problem. Instead of going down 6 steps, now we're going to go up 6 steps. So that's 1, 2, 3, 4, 5, 6. Now, it doesn't matter that we're going up. We want to write the equivalence statement by starting with the thing that's on top. So we're going to say 1 meter equals 10 to the 6th micrometers. All right, and I think you can see that this passes the common sense test, right? Because micrometers are really, really small. It takes 1,000 of them to make just 1 millimeter, and so it makes sense that it's going to take like 1,000,000 of those to fit into 1 meter. One problem that I sometimes see, okay, I don't want to put any ideas in your head, but it sometimes I see students do that, and it might feel right at first, but if you think about it, 10 to the minus 6 is 1 millionth. It's a very, very small fraction of something, and I think you can see that it just doesn't make sense that 1 millionth of a micrometer, which would actually be, something called a picometer, is equivalent to 1 whole meter. That just doesn't make sense. So always apply the common sense test when you're doing these problems. All right, now back to the worksheet. So once we're back here, when you set up the conversion factor, you just reproduce the number 6.2 micrometers times set up the fraction, so that's going to be 1 meter over 10 to the 6th micrometers. All right, remember this came directly from the equivalence statement. On the metric staircase, we had this, right? And so we're taking this equivalence statement, and we're putting one thing, on top and the other thing on the bottom, and we want the micrometers on the bottom so that they cancel out. And now let me grab my calculator here, 6.2. So on my calculator, I'm going to take 6.2 and I'm going to do a divide by 1 million. Okay, so 6.2 divided by 1,000,000 is, in scientific notation, 6.2 times 10 to the minus 6th meter. Okay, there we go. Okay, so I hope that's what you got. All right, so that's a few conversion factors. Hopefully that's helpful. Now let's switch gears and go to worksheet number 2. All right, this is on scientific notation, and I think I asked you guys to do, let's see, C and then D. And I think we did those in class. So let's take a look at G. I think I did G in one class, but for the others, let me help you guys out. Okay, let me get my pen going here. All right, so the number 2001, if we express that in scientific notation, okay, so get the right color here. So the decimal point is sort of hanging out just on the right side of the number, right? It's just to the right of the 1. So to express this in proper scientific notation, this decimal has to move over to this position. So there can only be one digit to the left of the decimal. So that's going to be 2 and then decimal 001 times 10. And since the decimal had to move 3 places to the left, that's going to be a positive 3. All right, so 2.001 times 10 to the 3rd. That's proper scientific notation for that one. Let's see, K. let's see if I can help you with K. All right, so here's the decimal. It needs to go 2 places to the right this time, and so that would be 1 times 10 to the negative 2. Okay, negative 2, because it had to hop 2 places, and because it went to the right, that's a negative. That has to be negative. So whenever you see negative exponents in scientific notation, it means that the number it's a number less than 1. And the number 0.01 is certainly less than 1. Okay, it's 1/100th. Let's see, N. N is in Nancy. Let's take a look at this one. Okay, N. So now, to move this decimal place, we got to go 1, 2, 3, 4, 5, 6. And so that is 1 times 10 to the minus 6th. And that's as simple as that. So because we had to move the decimal place to the right 6 places, that's a negative sign. And that's 1/1,000,000th. Okay. Let's see. Let's just do P, just for the heck of it. All right. So P, I'm going to have to move the decimal to the right 2 places to get a non-zero digit on the left side of the decimal. Okay. So now it's going to be 7.02000001. Okay, so 7.02 and then 4 zeros. 1, 2, 3, 4, 1. Times 10. And how many places did we have to move it? Yeah, we had to move it twice, 2 places to the right, so that is a negative 2. All right, and that's that. Okay, now let's move on. Again, I know this is we're just kind of dipping in a little bit to each of these topics, but I want to give you guys broad exposure and review before we move on too much further. All right, so on worksheet number 3, we were supposed to do numbers. Okay, where's my pen? My pen keeps disappearing. 3, number 3, number 5, number 8, and number 10. Okay, we did number 3 in class. So the question that we're focusing on is how many significant figures are contained in this measurement, and it's just these 3. Okay, this 0 right here, that doesn't count. And you may ask, well, why not? Well, first of all, I think you can see it's just kind of a placeholder. It's there simply to kind of visually anchor the position of the decimal point. All right, and if we go down here to the guidelines for significant figures, let's see here. It says zeros to the left of the first non-zero digit are not significant. All right, so let me go back. Okay, so we're looking at this number, and even though I did that, I just want to show you that I'm not just making this stuff up. Let me reproduce the number. It is 0. Sorry, my pen is giving me a hard time tonight. 0.123. Okay, so zeros to the left of the first non-zero digit. All right, so going left to right, the 1 is the first non-zero digit, correct? And so zeros to the left, which would be this guy, are not significant. Okay, and if you read on, these zeros are used to indicate the placement of the decimal point. All right, so this 0.08 contains only 1. That's the 8. This number contains 3, these 3, and so on. Okay, all right. I probably belabored that a little bit too much. All right, let's go to something like, okay, number 5. Number 5, I think you can see that, hopefully, that there's definitely 3, there are definitely 3 significant figures here, right? So there's this one, and this one. Those are obvious because they're non-zero. And according to the guidelines, Okay, if you look at the first one, any digit that is not 0 is significant. Okay, so you can always count on that. Then, if you look at rule number 2, zeros between non-zero digits are significant. Okay, so that means that this 0 and this 0 are significant. All right, let me clean this guy up a little bit. Okay, so there are 5 significant figures there. All 5 digits are significant. These two zeros are significant because they stand between non-zero digits. All right. How about okay, well, the answer to number 8 is 2. All right. So this digit, the 9 and the 8, are both significant. These zeros are not significant. They are simply there as placeholders. I mean, think about it. If we didn't use those zeros, then this number would simply be 98. But in order to express the number 98,000, you got to have those zeros there. But they're not significant. Let's check the rule. Let's see what the rule says. And, you know, just kind of humor me on this consulting the rules, because I want you guys to be able to interpret these rules, independently. Let's see here. If a number is greater than 1, then all the zeros written to the right of the decimal point count as significant. Okay, what about these guys? For numbers, yeah, this is the relevant rule right here. Okay, for numbers that do not contain decimal points, the trailing zeros, that is, the zeros after the last non-zero digit, may or may not be significant. Thus, 400, it may have significant figure. Let's see. Oh, I think this is a typo. Sorry about that. So it may have just 1. Yeah, that's supposed to say 1. There's a missing E here. It may have 1, 2, or 3. So let's go back to the actual number. Go back to 98,000. So the fact is you don't know for sure. But to be conservative, we're going to say these 3 zeros are not significant. So there's only 2. All right. This number, by contrast, let's look at number 9. Do you see the decimal point there? So it has trailing zeros, but because there's a decimal place there, that indicates that this is significant. So the answer to this one would be 4. This one would be 2. Okay. Let's see. I think that's the only ones I want to comment on right now. Okay. And the answer to number 10, which you need, is only 2. Only the 1 and the 6 are significant. These zeros, again, are merely to hold the place. All right. Okay, so I think I covered, in kind of a quick fashion, the, how to handle some of these problems, and we'll definitely do more practice on these in the coming days. Okay. All right. So thanks and good luck. See you tomorrow.